Hello students, this is your microprocessor teacher Ajay Sharma once again. I'm here with your new IC, that is 8259 programmable interrupt controller, right? This IC is a special IC and this is a part of your unit 5 of the microprocessor subject, right? So what for this IC is used? This is an interrupt controller. You guys know that for 8085 number of external peripherals come here and interrupt the microprocessor for getting the job done, right? And we know in 8085 and 8086 we have got only 5 interrupts. What are those interrupts? Is starting from trap, RST 7.5, RST 6.5, RST 5.5 and INT. There are only 5 interrupts. So at max 5 peripherals can be interfaced with 8085 at a present time. But by increasing when we want to increase the number of interrupts, we use this IC, that is 8259. This is programmable interrupt controller, and in parallel with microprocessor this IC is used in order to increase the number of interrupts there inside it, right? So how we see this IC? Let us go to the next slide. This is the introduction part of this. What is an 8259? 8259 is microprocessor is defined as programmable interrupt controller, that is PIC microprocessor, and there are 5 hardware interrupts and 2 software interrupts. There are total 8 interrupts in there. In 5 hardware interrupts in 805, 8086, 2 are software interrupts. That is of no use because it is generated by the programming. So at present 5 interrupts can come at present. Now what is a special thing and what for this 8259 we are using? By connecting 8259 guys with the CPU, we can increase the interrupt handling capabilities. This is the main objective why we are using this IC. We used to increase the interrupt handling capability, right? So 8259 combines the multi-interrupt input source into a single interrupt, and these interrupts are numbered from IR0 to IR7. There are 8 pins which are numbered here from IR0 to IR7, right? So now interfacing of 8085 and 8259 increases the interrupt handling capability. We all people know that this is how the interrupt handling capability is increased, right? So using a single IC 8259 with 8085 increases the number of interrupts from 5 to 8, right? Now coming on to the new one, features of 8259 in journal. What is an 8259? Let us see the journal features very quickly. Intel 8259 is designed to perform with Intel 8085, 86. It is multi-user. It can be interfaced with any of the common microprocessors. 8259 we are talking about can be programmed in level triggered and edge triggered. Level triggered, edge triggered, you guys know. This one is an edge and this one is a level. This one is an edge, this one is a level. This is about the duty cycle we are talking about. We can mask individual bits of interrupt. Suppose 4-bit, 8-bit interrupts comes, we can mask, means remove any of the bits as per our requirement. This is the beauty of 8259, right? So the 4th point is that we can increase interrupt handling capability up to 64 interrupt level by cascading further 8259 PIC IC, right? I mean to say, by interfacing single IC of 8259, we increase the interrupt to 8, but if we interface 8 ICs, 8 number of ICs 8259 in cascade, the interrupts increase 8 into 8 up to 64 interrupt levels, right? When we cascade further, okay? So now see, clock cycle is not required. The main basic question is that no clock cycle is required. So clock cycle is not required because there is no signal which connects to clock. It uses the internal clock of the microprocessor only, okay? So see here, now this is the pin diagram, the most crucial one of 8259. We know most of the pins, but just a revision of all that. This is CS bar, the most important pin. This is known as chip select. If you select it low, because there's a bar over there, bar is 1. So if we select low, so this is your chip select bar, and this one is your WR bar, that is a write bar, right? What is a write bar? If it is selected low, the writing operation will take place, and this is RD bar, that is read bar. If you select it low, read operation will take. Now here is a bidirectional data bus buffer, which is attached with the microprocessor for sending data and instructions, right? And this one is cascading signals, CAS0, CAS1 and CAS2. These three signals are used when more than one IC is cascaded along with the microprocessor. If I want to increase the number of interrupts more than 8, so more than one IC is cascaded there, right? Now you guys know this pin number 14 and the pin number 28. By this we power this IC. The power is given to this IC. Then there are selection line 1, that is A0. INTA is an input signal given to 8259 from microprocessor in response to pin number 17, that is interrupt. The 8259 sends the interrupt, means the highest priority interrupt will be obviously entertained by microprocessor. Na? So 8259 takes the highest priority interrupt and gives an INT signal to microprocessor. In return, it will give you interrupt acknowledge that yes, I have received your request. I will be just solving your problem in a while, right? And now here are the 8 interrupts, the beautiful interrupts which I am talking about, ranging from IR0 to IR7. In most general cases, mythologically, IR0 has got the highest priority in comparison to IR7, right? Now, there is an important pin over here, SP bar / EN bar. This is the pin which decides that this IC, which IC, your 8259 is used as a slave or a master, right? This IC decides as a slave or a master. SP stands for slave program, EN stands for enabling the master mode. If it is 1, it is the master mode. If it is 0, it is the slave mode. It is in detail, it has been talked later also, right? Now we'll see the pin description in detail, all the descriptions of the pins. 8-bit bidirectional data bus, I have already told, this is one address line is needed, naturally once you locate the address, then only the data will transfer. You guys know that direction of flow is controlled by your RD bar and WR bar. I am putting a bar over here, right? CS bar, you guys know this is connected to the output of address decoder. Once CS bar is low, then only this chip will be selected. Otherwise, it will not be selected, right? Interrupt requests are the output of the interrupt which is connected to INTR process. INT and INTR are means vice versa of each other. INT is given to the microprocessor and INTA is means generated by the microprocessor that yes, I have received it, right? So here are the interrupts from IR0 to IR7. These are 8 separate interrupt requests to be inputted to the PIC. There are 8 inputs which are there on the PIC. This is the pin I was talking about, SP/EN. If it is 1, it is the master mode. This IC will be using in a master mode, that is 8259. And if it is 0, it will be used in a slave mode, right? And these are the 4 pins from cascade 0 to cascade 3. These are the input outputs used when more than one PIC, means more than one 8259 ICs are used in cascade mode along with the microprocessor. Here comes the beautiful block diagram of 8259, and you can see there are 5 plus 3, 8 boxes are there, and we'll start from the interrupts. If we come on the left hand side, as we can see, there are 8 interrupts attached to this IRR, interrupt request register, right? This register acts as a reception, and it may happen that in all 8 interrupts, all interrupts come at a single time. In all 8 lines, interrupts come all. This what this IRR does, this is interrupt register request. It will receive all 8 interrupts. Like it is acting as a reception of a hotel. It is means accepting all the guests, making them sit on the reception, then one by one based on the priority order it will book the rooms, means the service will be given to each and every guest. So what IRR is doing, it is receiving all the interrupts at one time, making it to sit in this block, that is IRR. Then the work comes of a priority resolver. If all the 8 inputs are carrying interrupt at the same time, priority resolver will resolve the priority. The highest priority is of IR0. So IR0 will be serviced first, and once the IR0 is reached, priority resolver will say yes, IR0 has got a highest priority and it will be serviced first. So IR0 will be sent to ISR. This is interrupt service register. It will provide the service what is required, right? If it is a higher interrupt, some data is to be transferred to the microprocessor. So who will take all this decision? Here is the read-write logic, which is the brain of the whole IC, which is taking all the register. Once all the interrupts are requested, IRR receives, priority resolver makes a priority, and ISR is responsible to provide the service. Suppose the data has to be transferred to microprocessor, it will go by this to data bus, and then it will come to the main line, it will come to the internal bus, it will travel to the data bus buffer, and from data bus buffer here it will go to the microprocessor, right? Here it will go to the microprocessor, and in return, when the job is done, the same means line and the path will be followed coming return. Just see as the marker travels from the data bus, internal data bus to ISR, and then again it will travel to the interrupt. This is how the work will be done. This read-write logic is controlling each and every operation of that. This RD bar, WR bar, A0 and CS bar decide what operation is to be carried out, what operation is not to be carried out, and it will give simple instruction to the control unit and to the cascade buffer. See, this cascade buffer is a special block, guys, I am talking about, where these pins are there. See, cascade 0, cascade 1, cascade 2. This is actually CAS, not CSA. Both are CAS, right? So these are the cascade buffer is a special buffer which comes into the picture when more than one ICs are used in cascade mode. If only single IC we have interfaced with the microprocessor, this cascade buffer block is not required, right? Because then cascading of the IC will be not done. No? So if more than one IC is used, then only this cascade buffer will be required. Here is the SP/EN bar. If it is 1, it is a master mode. If it is 0, it is a slave mode. Now see what happens when this read-write logic control is there on the control logic. What control logic does? See here. Control logic gives the interrupt signal. See here, gives the interrupt signal to the microprocessor when a highest priority interrupt is received and it has been passed by priority resolver, and the service it reaches to the interrupt service register, right? Then it will give to interrupt to the your 8085. This side is your 8085, as I am trying to write it with the marker. This side is your 8085. It will give interrupt to 8085. Yes, boss, I have received the highest priority signal, and in return it will give a signal that is INTR or INTA. INTA will tell you what? This INTA will tell you that yes, I have received your interrupt, and immediately I will do your job, right? There is one more block, we will talk about this also. This is interrupt mask register. If any of the bits of the interrupt at any level needed to be masked, means to be removed, this register, interrupt mask register, will do that, right? And it will, after masking, it will transfer the data by this. You can see data bus buffer, it will go over here, and after masking it will go towards data bus and to the microprocessor, right? Here is the microprocessor where it is all joined. These two are the control signals, and this is the data which is reached here. So in totality, I repeat the operation once again. From here, any interrupt will enter. First of all, it will make to sit there in IRR. This is as a reception. Then the priority resolver will resolve what interrupt has to be serviced first. And this interrupt service register is the service provider. It will immediately provide the service. The control logic will issue the interrupt command to 8085. In return, I will receive the INTA. This is actually INTA. I am writing it A over here. And then the transfer of the actual data will do like this marker I have shown you, right? This is how by the data bus buffer. What is the data bus buffer? This is a buffer which matches the speed between your IC 8259 and 8085. to make the operations smooth. Read-write logic control is controlling the whole operation. Cascade buffer comes into picture if more than one IC is used. Thank you. So this was all about the block diagram. We'll go further. This is about the blocks which we have talked. These are the definitions for you to study. Because in the video you can study, you can pause it and study what is a data bus buffer. This is a mediator between your 8259, 8255 by acting as a buffer, right? Read-write logic control, this is having CS bar pin which makes it active. I am putting a bar over here and this pin is active low, then only it will perform. And then we have got your RD bar and WR bar. I am putting a bar over here. These two pins are active low, used for read and write operation. This is the block which is controlling the whole operation. Then there's a control logic to interface between the microprocessor and 8259, sorry, and then interrupt a request register. What is a request register? It stores all interrupt levels which are requesting for interrupt service. It is acting as a reception. It makes to set all interrupts, then the service will be provided. And then there comes the interrupt service register. It stores interrupt level which are currently being executed. The interrupt, it is stored which is getting provided service at present. So this is currently being executed, means the service is being provided to a specific interrupt which has got highest priority. Then the mask register, it stores interrupt level which has to be masked by storing the masking bits of the interrupt level. We have discussed there, right? So now we'll see to the next pin. What is this? These are the priority resolver. Priority resolver, we know that it resolves the priority, that which is to be done, which is not to be done. It resolves all the priority. What are the priority? IR0 has got the highest priority, IR7 has got the least priority. Then the cascade buffer, I have told you beforehand, if we are using more than one IC, then only this cascade buffer will come into picture, and this will increase the interrupt handling capability. Maximum how much interrupts we can handle, that is 64 interrupts we can go for, right? 64, because 8 into 8 is 64, right? Now these are the operations or the operating modes of 8259. Basically PIC is to be initial and control operation. So in simple order, the operations are very simple, which I will show you, and this is the priority which is set by priority resolver. So first of all is fully nested mode. Nesting, you know, to go the loop on and on to indefinite time. This mode is entered after initialization unless another mode is programmed. It goes on to continuing after unless until it is initialized by another mode, right? We all know priority from 0 to 7 we have discussed before also. The second one is end of operation. End of operation is also known as EOI, and the in service is bit can be reset either automatically following the trailing edge of the last sequence. Trailing edge and rising edge, you know, from where the duty cycle rises, it is rising, and from there the flat bottom goes down is the trailing edge, right? So this is end of operation. And end of operation command, you see here, end of operation may be issued twice in the cascade mode, once for the master and once for the corresponding slave. Means this is issued twice for the master and the slave at present. The next one is your automatic end of interrupt, right? This is an advanced one of end of interrupt. This is an automatic version. This is also known as AEOI. You have just to learn all these modes and understand what are these. I have taken the most important ones is there. In this mode, the 8259 will automatically perform a non-specific end of operation. Means we don't have to give a command of end of operation. It will end it automatically, just as similar at the trailing edge of the last interrupt, right? Then we have got an automatic rotation. This is also known as equal priority devices. In some applications, there are number of interrupting devices which has got an equal priority. What is an equal priority? All have got a same priority, and we don't have any idea which is to be serviced first and which is to be serviced last. So this is known as your equal priority. So setting this mode, all the interrupts which are receiving over here will be serviced once, and then the first one which was serviced gives the another. Means first we'll complete the circuit, then we'll go there. In worst case, until each of the 7 devices are serviced at most once. All the devices are serviced once, then the second round will come in this mode. Now this is interrupt mask. Mask, you know, so removing any bit means masking any bit. Each interrupt request can be masked individually. This is an interrupt mask mode, and this is known as IMR, that is interrupt mask register program through OCW. Then we have got a special mask mode. This is a priority based special mask mode. This was in generalized interrupt mask mode. So masking IR channel does not affect other channels operation. Means if I mask one of the channel, others do not affect. What is there in a special mask? In some applications, we require an interrupt service routine to dynamically alter the system priority structure. Means the VVIP culture we are talking about under the software control. In some of the special cases, we want to fortify, we want to change the system priority, the generalized priority mode which is already set inside that. Then we use a special mask mode, right? Execution under software control, right? There's an example also there. For example, the routine may wish to inhibit lower priority request. Means if I want to change the routine, that lower priority will be serviced first. So this is a special mask mode. Then we have got a specific rotation mode. A specific priority means the programmer can change the priority by programming the bottom priorities. Means any interrupt of our choice we can make the highest priority. So this is a specific rotation means we will rotate according to the priority what we have made as per our requirement. There is an example also there. If IR5 is programmed as the bottom priority device, then IR6 will have the highest one. This is how we run. This is the poll command. Means polling, we take options of all, then perform. Polling you must be know, poll exit, exit poll you all know. Means the maximum people what will say, it will help. It will be done, right? That is a poll command. In poll mode, the INT output functions as it normally does. The microprocessor should ignore this output. So what basically it does, thereby disabling its interrupt input service to devices is achieved by software using a poll command, right? Means disabling the interrupt input, the regular interrupt, or means which is all preset and set in a program, these are disabled and the service is achieved by software using a poll command. Poll command is taking means which of each and every one and performing. That is known as poll command. So this is all in 8259 we have giving you my official email ID. If still you have got any problem related to 8259, that is an interrupt controller, you can ask. Thank you so much for hearing this video, watching this video. Thank you so much.